Good afternoon, everyone, and thank you for joining us. We are very excited to have you here this afternoon as part of our FHIR introduction session. And before we get started, I just wanted to run through a few quick announcements before we kick off. During the session, if you have any technical difficulties, your first step is going to be to log out of the Whova app and then sign back on. If you still have difficulties after that, please go to Zulip to the DevDays support team stream. That will be the first line of defense when you have any issues that we can help you address. Regarding the Q&A, to post questions during the presentation, please use the Q&A box, as we will have moderators answering the questions during the session. And then we will also have questions available to view after the session has ended. Regarding your video and microphone, please do not attempt to enable them unless you are prompted by the presenter or the moderator. We've muted everyone by default, and if you can't hear or see something during the presentation, please use the chat box to let us know. We do very much value your feedback, so after the session, please take just a minute or two and complete the survey that is located in the app. And then lastly, if you are interested in our DevDays swag, take a moment and look at our online store, the hl7.me/merch. We've got some DevDays swag and some FHIR swag that you might find interesting. So with that, I would like to introduce our session speaker. Many of you may already know Simone Heckmann. She is CEO of FHIR. She has been involved in developing and testing V2 to FHIR mappings for many years, and she has given numerous FHIR training courses in Germany as well as abroad. She is also chair of HL7 Germany's technical committee for FHIR and a board member of HL7 Germany. The moderator for our session is Matthias van der Wieling, who is with FHIR. So with that, if our speaker is ready, we will get things kicked off.
All right, thank you, Pat, and welcome everyone to the introduction to FHIR. Before we start talking about FHIR, I would like us to talk a little bit about HL7. HL7 is what we call a standards developing organization. It's the organization behind the FHIR standard. And this organization consists of volunteers from all over the world that work together in so-called working groups in order to develop standards and cooperate. And these are specialists that are highly focused on particular parts of the FHIR specification. And you can join any of these working groups if you like by subscribing to their email list. And then you can cooperate with these international experts and help to develop HL7 standards. HL7 has been around for many decades. It goes back to the mid-80s, mid-1980s. That's when the first working group meeting was held. And that's also when people began to develop the HL7 standard. The first product that HL7 developed was the HL7 version 2 standard. And this development has been going on for many, many years. And HL7 version 2 is probably the most successful product that HL7 ever created. There have been many other standards along the road, but today still HL7 version 2 is highly prevalent all over the world. And that sometimes creates a little bit confusion because people often say, when they say the HL7 standard, they quite often refer to HL7 version 2. And that sometimes creates situations where you will hear people say, we're not using HL7 version 2 anymore, we are using FHIR now. Or we're not using HL7 anymore, we're using FHIR.
Can I interrupt you for a second?
Yes?
Your sound is really bad and you're very choppy, so we can't really hear what you're saying. Could you maybe check your internet connection?
I'm
Fix your
sorry
microphone.
about that. Let me see.
Oh, it's better now.
I will
And
try
Simone,
to change my network.
Simone, this is
And
Josh. Just 1 second. I'm going to get Alex back on here 1 second.
can you still hear me?
Yeah, it's still a bit choppy.
All right, Simone, is that any better? Can you test one more time, please? And I do apologize for the delay. We are working in the background here. I will let you know when we're back up and running. Thanks for your patience.
Can you hear me? I
Yes,
cannot
we can
see
now.
Simone, we can hear you.
my screen anymore.
All right, give me 1 second here. All right, you should be getting it there, Simone. Are you seeing it?
Okay. Hold on. Okay, this should do it. Do you see my slides?
Yeah, we can see the first slide there.
Perfect. So let's go back to where we left off. I'm sorry about that. I hope the connection is better now. Okay, so we were talking about HL7 version 2, which is often referred to as the HL7 standard, and that creates a little bit of confusion sometimes. If any one of you has never seen HL7 version 2, this is basically what it looks like. You can see it's a child of the 80s. It's 30 years old. It's older than the World Wide Web, but it's basically the way that communication has been all these years in healthcare. And the way it is now with HL7 version 2 is that it's dominated by this message-driven approach to communication. We have the primary EHR sending out messages to any receiving system whenever the primary system sees fit, whenever something happens in the primary system. But the way that the end user clients access this information is highly proprietary. So the right side of this communication between the end user application and the back-end server is not really standardized. So every end user system basically has to bring its own server and then somehow figure out how to get access, how to give access to that data. In the new world, however, that is primarily dominated by mobile devices, these devices don't work that way. They expect a server to just be there somewhere in the cloud, to be ready for them, to give them a query-driven access to the data, to provide an open API, to deliver JSON encoded data via HTTP. And they really can't use that mechanisms that HL7 version 2 provides. So these three guys, you've already heard Ewout talk earlier, and given the introduction, you will hear a lot in the next couple of days from Graham Grieve, the product manager, and even Lloyd McKenzie. These three guys decided back in 2011 that the world was ready for a new standard. And the idea that they had was to create an open API for primary EHR systems that would allow any device to query data whenever it needed access to the information. And so also give access for mobile devices to retrieve the data. And the acronym that they found for their invention was FHIR. FHIR stands for Fast Healthcare Interoperability Resources, as you probably know. Healthcare interoperability goes without explanation, but fast is there because the focus of this new standard is to provide fast interoperability solutions. And resources, these are basically the information bits and bobs that we are pushing around in FHIR. FHIR goes back, as I said, to the year 2011. That's when the first draft was published. And immediately after, there was a first connectathon. That was basically an invitation to implementers to try out this new standard, figure out how it works, give feedback to the specification, tell people whether it works, what didn't work, whether something was clear and understandable, whether other things seem to be overly complicated, and this feedback informed the further development of the FHIR specification. There were regular releases, frozen versions of the specifications that implementers could use to develop prototypes or even productive systems. They were called DSTUs. You will probably hear a lot of people talk about DSTU versus STU3. So this stands for Draft Standard for Trial Use. Those were these early releases of FHIR that people could use to build specifications on while the standard was still developing. In 2017, they decided to drop the D. It was no longer draft, it was actual standard by then. So we had STU3, and the current version that we have is R4, which stands for Release 4. This is the first version that has normative content. So parts of the specification are now stable. They will no longer be changed, at least no non-compatible changes anymore. And we will have further FHIR releases in approximately a 2-year away from, in a 2-year cycle, where more and more parts of the specification will become normative. The FHIR Manifesto is a couple of basic rules that apply to the development of FHIR. First of all, there's a focus on implementers. The FHIR standards really tries to support implementers in the development of software. In consequence, there is the 80% rule, which means that stuff is only included in the FHIR specification if it is used in 80% of the cases. If it's too specific to make it into the 80% rule, it will not become part of the standard, and you will have to use extensions instead. The purpose is to keep the standard as simple and straightforward as possible. FHIR is using established web-based technologies whenever possible, so that implementers don't have to learn new technologies. They can reuse what they already know, what they already have. We are trying to represent data as human readable as possible. And there's a very strong focus on community, on offering support to the community. And the last point is scalability. We need a standard that supports, that delivers easy solutions for easy problems, but also allows to create very complex constructs, because a lot of things quickly turn very complex in healthcare. I like to think of, when people ask me what FHIR actually is, I like to think of it as like one of these Lego boxes. I hope that's not a European phenomena. I hope everyone knows what these are. These are basically, you know, assorted pieces arranged neatly in these little compartments. And as long as you have enough of these pieces, you could basically build whatever you want. And the same thing is true for FHIR. And when you look at the front page of the FHIR specification, you will actually find something that looks very similar. You will also find these neatly arranged compartments which have different parts of the specification. You will find a compartment that has parts for security and privacy, one for terminology. You will have the bits and bobs for administrative purposes. Then we have like special parts for clinical department, the gears for medication, the wheels for workflow management, the sticks of financial management. They are all there, these different parts, and they are arranged in these compartments, so you can easily find the right piece you are looking for. There's another layer to this. We have this resource overview that you find in the specification that again gives you an overview of all these different parts that exist in FHIR. And you can see that these resources have numbers behind them. It's either a number or this green box with the N in it. And that's what we call a maturity level. It's an indicator of how well tested a resource is. And it ranges from 0, which means that this resource is basically just a draft, first draft, goes to 2, 3, 4, depending on how widely the resource has been tested and even used in production by different companies, until it finally reaches the normative status. So you can see not all resources are normative yet in the current version, but there are some, and basically the most important ones, that are now stable and will no longer be changed. If you want to take a closer look at what any one of these resources looks like, you can just follow the link, and that will bring you to what we call the tree view. Let me go to the patient resource and show you what it looks like on the inside. In this tree view, you can see the different elements of the patient resource. You can see a cardinality column that indicates whether these parts are optional or mandatory, whether they can repeat or not. Then we have the type column that you can use to identify the data type of this element. We have complex data types. These are the ones that begin with capital letters like human name or address. They will have different subfields. And if you want to inspect any one of these data types, again, you can just follow the link right there, and it will land you on the description page for the data type. In some cases, when there is a terminology binding, basically a list of allowed values for a specific field, you will also find another link in the short description column that will reference the terminology value that allows you to check out what values are allowed for the specific element. This is an example of what a resource might look like. So this is a patient resource that has been XML encoded. But if you use XML encoding or not, it's optional. You can also use JSON encoding. The rule of thumb is that FHIR servers should support both representations, and FHIR clients can pick whether they want to use JSON or XML encoding. Sorry, let's go back to that one more time. In the blue background, you see what we call the narrative. That's a human readable representation of the contents of the resource. And you can see that this just uses simple HTML markup. So whenever machine-readable interoperability doesn't work for whatever reason, you can always rely on the data being there in a human-readable format. The yellow box shows you an example for an extension. That's what you use if there's any part missing from the FHIR specification. Whether you need something that didn't make the 80% rule, then you can use the extension element to the FHIR resource. In the green box,
your sound is falling off again at some points.
And Simone, I have disabled your video there.
Yeah. Let's see. I'm getting a message that there's a problem with system resources, which is weird because I have nothing else running, so it's probably not network. I'm just hoping that that it will get better. All right, so let's talk a little bit about exchange paradigms. FHIR is mostly seen as a web-based standard that provides access to the REST paradigm. But that's the option you have. Basically, use any kind of communication. You can even use messaging the way FHIR version 2 does to move FHIR resources around. And basically, you can do whatever you like. There is no mandatory protocol that you have to use. As long as whatever you are transporting is a valid FHIR resource, you can do that, because quite often you will have to use whatever national infrastructure is already established in your country. So FHIR is basically giving you the freedom to do that. Nevertheless, I would like to take a closer look at the REST paradigm. If any of you are not technical people and never heard of REST, don't worry, we all basically understand how REST works because we're doing it many times a day. Whenever you open a browser and enter an address and you will see the web page, that's basically a REST interaction happening right there. REST basically says that all resources have a unique URL. The way you can see it here in the browser.
And Simone, this is Josh. I apologize. I know you said it was a resource thing, but your audio is still very spotty. If there's anything else open, can you please close anything you're not using just to see if that helps clear it up?
Nothing. I have Zoom and PowerPoint running. Okay.
All right. Thank you. I'm sorry about that. I'm working with Alex in the background here.
All right. Okay. Thank you. And actually, I'm not really using that much CPU. I don't really know what the problem seems to be.
Are you in direct line with your router or directly connected via hardwire?
No, I'm on Wi-Fi.
Okay. All right. Yeah. And I do apologize. The audio is spotty from time to time. Sometimes you're coming in clear, sometimes not. So. Okay. We've got about 10 minutes left before the 5-minute warning. So if you want to just go ahead and please continue, and I'm working in the background here.
Okay, great. Thank you. So the same principle that we use to retrieve like a web page from a web server is used. You can use to retrieve a patient resource from a FHIR server. You basically need to call the address of that resource, and then the server will return the information back to you. And you have a choice between either JSON representation or XML representation, whereas in a web browser, it's basically always HTML that you need to get. Quite a lot of times, you may not know the URL of the web page that you want to look at, so you have to use a search engine. And what happens when you type a search parameter into a Google web page, for example, is that your query gets encoded into the URL and sent to the server, and the server will reply with a list of possible matches. And the same thing works in FHIR, if you don't know the URL of the patient resource you want to look at, you can basically encode a query into a URL, send it to a server. Here, for example, we are looking for patients with a given name John, family name Doe, and a gender male. And this query gets sent to the server, and the server again will respond with a list of FHIR resources that match your search criteria. So this is the very basic principle of REST communication, but again, it's not the only way to exchange FHIR resources. When people ask me about FHIR, a question that I hear quite a lot is whether FHIR is going to solve all the interoperability issues that we have with systems, not being really interoperable, and every system interpreting a standard a little bit different. And my response to that is that the expectation that because two system vendors decide to implement FHIR, that they will be completely interoperable is the same as giving Lego kits to children and asking them to build a house and expecting them to return to exactly identical houses. That's not going to happen because everyone is going to use different parts, put them together in a different way. Maybe these children have different ideas and different concepts of what a house would look like, depending on what their house looks like. And so this is not going to work unless you add a construction plan to the kit and give it to the children. Then they will know exactly what to do. They will know exactly what you expect them to build. So the most important part for achieving interoperability with FHIR are the implementation guides. And implementation guides are not just something that is added to the standards, they are a part of the FHIR specification. They are resources themselves, so they can be searched and accessed and exchanged through the FHIR API. They are both machine and human readable, and they contain the profiles that describe how to use a specific FHIR resources in a given context. So basically, it's the implementation guides that make FHIR an interoperability standard. And so it's very important that when you start to implement FHIR, that you have an implementation guide that you can build on. Then that will give you the guarantee that there will be other people using the same implementation guide that you will end up being interoperable with. Finding an implementation guide can be quite a challenge. It depends on what you're looking for, but a good place to start is the implementation guide registry, and also a good place to start is attending FHIR DevDays, because there will be a lot of sessions and talks about different implementation guides. So here's one way of finding appropriate implementation guides. And the most important aspect of FHIR is probably that you should never work alone. Going back to our example with the children building the houses, you can easily imagine that if you put these children in different rooms and make them build these houses where they cannot interoperate, where they cannot communicate and they cannot see what the other one does, they will end up with vastly different results. If you, however, sit them next to each other where they can communicate and see what the other kid is doing, they will not only end up having houses that are more similar to each other, because maybe they looked at what the other kid was doing and thought, oh, that's a good idea, I'm going to do the same. But they will also finish faster because they can help each other out and see what the other kid is doing. And so the same thing, the same principle applies to FHIR. That's why FHIR is a community-based standard. We need to talk to each other while we are developing solutions. We need to find common solutions that everyone applies and that help everyone. And the basis to do that is the FHIR community. And you can join the community as simple as signing up to the FHIR chat. And that will bring you to a huge group of people that have been working with FHIR for a very long time. There are very new people in this chat, and everyone can ask questions. Everyone will get responses from other people. And I really encourage you that when you sign up for the first time to this chat, to really take your time and browse through the streams menu that will show you all the different groups that are there worldwide. And if you are not based in the US, if English is not your native language, you may even find a stream that is dedicated to your country where people will communicate in your language, and you can join them and discuss FHIR in your part of the world with other people. And depending on what your special interest is, whether you are using HARP or the .NET library, you will always find a group there where people discuss about this specific aspect of the FHIR standard. So with that, I would like to show you one more thing. You know that FHIR wordplay is a funny part of the community. There's a lot of funny names for products and things like that. And in Germany, FHIR basically means party. So when you, so you can imagine that we have our very special own brand of FHIR wordplays. So when I wish you frohes Feiern in German, that basically means have a nice party. And that's basically what I'm wishing you all, that you can enjoy DevDays, that all the next sessions will not be as problem-ridden as this one was. Yeah, really enjoy yourself and get involved into the community and meet nice people. And I'm hoping you're having a great time. I know all the past DevDays have been really wonderful experience. And so I hope this one will be as well for everyone, even though we are not meeting in person. And yeah, since we had a couple of problems, I probably overcompensated by talking really fast during the parts in which the connection worked. So I'm finished a little bit earlier than I should have. So I'd be very happy to answer questions if anyone would like to ask me anything, or if maybe a part of this presentation that you would thought was very interesting but didn't go through because of the audio issues. I'm happy to go back to these slides and repeat a little bit of what went missing.
Thank you very much for this very interesting presentation. I have a question in the Q&A. The question is, what are some of the projects you've seen that migrated from HL7 version 2 to FHIR?
There's actually not a lot of migration going on, because where HL7 version 2 is dominating is basically moving administrative patient information around. And that is working quite well. I mean, version 2 probably doesn't looks very unsophisticated compared to FHIR, but it's working. It has been working for many, many decades. And you know, never touch a running system. So if HL7 version 2 is good enough for the purpose that it fulfills, there's no reason to move to FHIR. And I basically expect that we will be seeing HL7 version 2 interfaces 10 years from now. They will not suddenly go away. So people have been focusing more on the aspects that HL7 was not good at, or where there have not been any prior standards, which is basically the places where you need these API-based approach. So HL7 version 2 had very basic functionality for queries, but they did not receive a lot of implementation, and it wasn't very well standardized. So I think that is probably the place where HL7 version 2 will be first replaced by FHIR, because query is not really something that HL7 version 2 is good at. So whenever you need a query-driven approach, that's when FHIR becomes interesting. If messaging is working for you, if what you are exchanging is, you know, structured, simple, flat data, and HL7 version 2 is enough for that, you know, don't touch it, just leave it be. and tackle other problems using FHIR. I think that's the message that I would like to send. Of course, what we've been trying to do was in places where there was no FHIR support whatsoever, and all you had was a version 2 data stream, that we were trying to basically plug into that data stream and extract any information that we could out of the V2 messages to populate a FHIR server and to make the information available for FHIR-based devices. That was mostly administrative data and lab data, because these are information that even in version 2 are structured enough so that you can easily extract FHIR resources from them and then make them accessible to FHIR-based applications.
All right, thank you. We have a few more minutes. Someone asked to see the narrative slide again.
Yeah. All right. The thing about the narrative is it's basically an HTML representation of the machine readable stuff that is in a FHIR resource. And I think I misspoke a little bit. I said that you could rely on the human readable representation. That's not actually true. It's not mandatory to have this narrative in your resources, because when you have machine based communication, if you're delivering data to let's say a registry where there's no human consumer on the end, there's really no benefit in having that human readable representation. This only makes sense if there is a human recipient on the other end that might be interested in looking at this information, even if the system cannot process the information. And that's basically where this narrative becomes interesting. That gives you just a plain HTML representation of all the machine readable structured data that is in the body of that resource. And so that's basically a fallback mechanism, that if your system, for example, receives a resource type that it didn't expect and it cannot process because it doesn't have any business logic for that, it can still take this human readable part and make it available to the end user. So the information is not getting lost. That's basically the purpose of this narrative. And usually your system would use some sort of template to automatically generate this simple HTML table, for example, the way we see it here, to transport this information around.
And we have 1 minute left.
Okay, one more question.
Could you please give a short overview, what is terminology and mapping about?
This is difficult to make it in 1 minute because these are two very different parts. Okay, terminology in general is about how you use coded information. For example, when you want to encode, not just use plain text to describe a diagnosis, but use some kind of coded representation so that you can have statistics, that you can have machine readability. And in FHIR, the exchange of not just the codes, but the terminology itself is also possible, because a value set or code system can also be represented as FHIR resources and can be moved around using the FHIR API. So you can not only access data with coded information, but you can also access a list of all the available codes or all the allowed codes for a specific field through the FHIR API. And that makes managing terminology, which can be quite a huge headache when you're implementing in a healthcare domain, a lot easier for people who implement FHIR solutions.
And Simone, I do apologize. We are at 2:40.
All right. Okay. Then I will follow up on the chat to that.
Yep. And please do, as she mentioned, follow up on the Q&A in Whova. And thank you very much for attending and bearing with us through these technical difficulties. And check your agenda in Whova for your next meetings. Thank you guys very much, and thank you so much, Simone.
Thank you. Bye.